my name is Philipp Fehringer and I got the following gig proposal for you. I designed a helmet that I want to realize with a 3D printer. This helmet, as you can see, consists of 5 main elements. The front half, the back half, the protective mesh which will go over here to protect the facial area, the articulated front throat defense and the articulated neck defense. The model you are seeing here is a very first model I built with thermoplastic to get an idea of the parts working together and does not resemble the final edition of the project. What I need you to do is to build this helmet in Blender such that it can be point 1 printed with a 3D printer and point 2 easily be adjusted to another head I load into Blender. Means it should adjust to a new head I load into the file. All of these parts will be printed separately from the others, but in the file will and must always be related to other parts, so that, for example, if I alter the back half, which is, as you can see, overlapped by the front half, the front half has automatically to adjust to these alterations. What does this mean exactly? First, I would like you to build a helmet according to the following rules. The thickness of the material itself should be 3 millimeters, but thickness of the material should be able to be altered. The helmet should have a distance of 1 centimeter to the head to allow the application of padding. As you can see, I tried to produce this with some styrogum. The helmet head distance should also be able to be altered. If I later find out that I need thicker padding for the helmet, this should be able to be adjusted easily. The surface of the helmet itself should also be able to be altered. For example, now, as you see, it's a closed massive surface, but if I decide to add a lot of ventilation holes, that should be no problem. Okay, let's talk a little bit more about the specific parts. The front half. The front half of the helmet, as you can see, covers the face and the head, about right to the ears. So it's looking like this, but we will draw it a little bit further back in reality. Please note that on the model there are bumps where are the ears. I want these areas built flush, so no bumps. What we will do in Blender is when we have a head and we have the ears, we will pick the ears and shove them a little bit into the head so that we just have the maximum contour of the ears for the padding. Otherwise it's not needed. Since we will have 1 centimeter of padding, we will try to compensate with cutout padding room for the ears. There is a big open area here, the field of view, which later will be covered by the protective mesh. The protective mesh will be flush on top of the front half, so which means it will around about here everywhere sit flush. So we will have an overlapping area here around and with a ridge. I think you can imagine what I mean. The front half, as I said before, is overlapping the back half, and the two halves will be joined in this area, which is quite a mess, as you can see, with some kind of hinge. And the hinge will be flush with the front half, so there will also be some ridges here. Let's talk about the special sub-theme of field of view. I'll take this off. A second. Now, the field of view is made up of two angles. If you try to sum up your own field of view, the one is the horizontally angle, also how far can you look to the side, the perispherical vision you can get if you look at this side, and the other is the vertical perception. And what you see here, these lines, I tested out what that this line marks the border at when I have an object which is about 1 centimeter thick, when it starts to appear in my perispherical view. So yes, what I want you to do is to create an object with the perispherical angles, the horizontally and the horizontally and the vertically. And why do I want you to do this? Because we are going to determine the helmet's field of view on different heads with it. I want to drag that object to a horizontal line of the eyes, because the eye line is our point 0, and determine the helmet's field of view on different heads. So I want to drag the object to the horizontal line of eyes and into the face. Imagine like I guess it will be some kind of elliptical balloon stuff like, and we push it into the face. And when we push it into the face and to the line, these border lines should automatically come out. So, okay. Now, a little bit of extra. What you can also see here on the front half is a little ridge below the jawline. This ridge is, as you can see, used as an anchor point for the articulated throat defense. Now, sub-theme protective mesh. What you see here is also some kind of prototype model, just to help your imagination. The protective mesh obviously protects the face. Please note the following details. Material thickness is 3 millimeters, and should also be able to be altered. The size of the holes is 3 millimeters. Distance between the holes should also be 3 millimeters. The protective mesh is flush with the outer shell of the helmet. Also, it is overlapping the front half on top about 2 centimeters. So here, above from this point, 2 centimeters. These 2 centimeters will be massive, so it's about this part here, like this. Not mesh-like with a few holes, but it will have some holes in it so that it can be riveted to the front half. It doesn't fit over it now, but I think you get the idea. Okay, let's move on to the back half. So, the back half of the helmet covers the second half and back of the head. As said before, there is an overlapping area where the front half is on top. The bottom line of this is like the front half very close to the jawline, as you can see here. Please note that the bottom line of the back half makes an arc. I don't know if you can see it here. Let's take it off. So it makes an arc. It makes it an arc so that it's possible to tilt your head backwards. Otherwise it would cut straight into your neck. So, and as you can see, the articulated back defense will also be mounted to the back of the head. The articulated throat and neck defense on this model are a very primitive display of what I want to build and to which parameters I want to adjust. These pieces function like medieval armor and such that the single parts, which you can see, check, 1, 2, and so on and so on, are joined in reality, not like in this model, via rivets and a textile band which allows for compression of the elements, just like you see here. The throat defense and the neck defense follow some very simple orientation lines, but for the first part of the gig, we will concentrate on the helmet itself. We will work this out later. So that's it. I hope you have enough information to make me a gig proposal, although I think you might have a lot more questions. Please use one of the 2 contact forms to get in touch with me. So Skype or WeChat, if possible. And we'll talk about else later. Well, I hope I got you interested. See you.